Howdy, we're Sort-Ware Solutions, and today we will be presenting our Demo 1 slides. First, let's introduce our stakeholders. My name's Lewis, I'm the project manager and test engineer. Caitlin and Alex are our mechanical engineers, Mark is our hardware engineer, and Darshni is our software engineer. Dr. Porter is our project sponsor, Dr. Hudson's our technical advisor, and Ms. Gagan is our financial advisor. As a brief overview, we will cover what our project is, go over our labor and financial statuses, and then finally go over our technical slides, including our demo.
Sales data shows that there's a growing consumer base for these trading card games. However, sorting them is very time-consuming. So there's a need for an efficient card sorting process. Our solution is an automated card sorting system capable of sorting Magic and Pokemon cards by their card type, their color, and their price. How it works is the user will choose a sorting parameter. Our device will then scan the cards, obtain its data through an API, and then it will sort it accordingly in its appropriate bin. 4 hours this week, we all predicted 10 hours. For actual, we all went above or close to the 10-hour mark. Next week, we also predict another 10 hours, giving us an estimated remaining labor of 400 hours left, with 8 weeks remaining.
Moving to our financial status, based upon our expected budget from last semester to the current items we have purchased as of this date, we found that our total sum of actual spending is $10.48 under what we previously planned.
We're going to be starting off by presenting our 3D printed prototype as well as a fully functional user interface that is where the user is able to select parameters as well as start the process, which triggers the computer vision pipeline. For the user interface and the computer vision process, user is able to select sorting parameters as well as being able to start the sorting process by clicking on a play button. Then the computer vision is able to isolate identifiers and send the identifiers to the API to obtain details of the card such as price, type, and color. So for the mechanical subsystem prototype, the initial printed designs of the dispensing components and the Geneva mechanisms are printed. These parts allow for initial testing of the dispensing and rotating mechanisms. As for the software demonstration, the procedure to do this demonstration is by starting the user interface, then selecting the sorting parameter and having the pre-scanned cards ready in file, then pressing play to start the sorting process. When the play button is pressed, it processes pre-scanned images using OpenCV and reads the cards using PyTesseract and then isolates the identifiers. These identifiers are then sent to the API to obtain details such as price, type, color, or category, and the live log of each individual card is also displayed on the bottom. Some possible issues are cards not being able to be identified properly due to blurry image or even improper lighting. So here's a quick demo of the user interface. So starting off, the user is able to choose the parameter that they want to sort by. Here we're showcasing the Magic the Gathering and the parameter price. After the user presses play, the system then begins processing each scanned card using OpenCV and Tesseract OCR. The software reads the text on the card and extracts the identifying information, which is then sent to the API, which then returns the card's data, as mentioned before. Here on the screen, you can also see a live log. Each entry corresponds to a card being processed. It shows the identifier that was detected and the information which is retrieved from the API. On the right side, you can see the active sorting parameter, so you can track how the card is being categorized in real time. To also make this clear, I'll also show the folder containing the pre-scanned images. These are the images that the system is reading from. I'll also showcase the API we are using to fetch the card detail. So for example, this is the Scryfile API. This is where we get values like the price, type, category of each individual card, which is essential for the sorting decision.
For the mechanical demonstration, we have it split up between the top and bottom components of our dispenser. This is the demo of the top components responsible for dispensing cards. Here we have our initial card stack where cards will be placed in at an angle. Here we have 2 slots to be connected to the structure using dowels. Here we have 1 axle as well as 1 wheel of each size. There will be more of these printed later. There will be an axle here, one affixed at a point along here, and one going through these slots. We'll have these larger wheels going on these sides, and one along this axis as well. 2 of these wheels will be on the outside, connected with the belt driver to be powered by one motor. Smaller wheels will be placed along this axle here. These will be stationary. From there, we have our motor mount, also connected using dowel slots that will slide down into place, aligned with the motor and the wheel. Here we have our mini stepper motor that will slides down and then into the wheel to power those. Here we have our scanning position that will be slid right there, and our servo arm will slide into place under. Whenever the servo is powered, it will lift up the arm. This initial design has the card lifted to be almost flat where it won't slide out of the slot. Our next design will have more of a hook so that it stops cards as opposed to lifting them, so they stay at this angle. From there we have our camera holder. There will be a slot to account for the servo arm. Inside we'll have a spot to attach an LED, and we have the spot for the camera lens to look through that slides over. This is an initial design which does not account for the length that we added to the scanning position, but there is already a model for the corrected length. Camera looks through here to take pictures of the card.
For the bottom components, we have the center and driving wheels of the Geneva mechanism as well as the gear connector. As we continue to print parts and connect subsystems, we do have the risk of issues with our interference bits. We are continuing to research tolerances to try to prevent this, but we're also printing early so that we have time to correct any issues that pop up. These are our prototypes for the Geneva mechanism. So we have the gear connector here, which will ensure that each axis is the correct distance from each other. This is our center driven gear and the driver gear connected to the stepper motor. So once the center stand and the motor holder are printed, the components will fit together to support the top assembly. To show how the rotation works, the driver gear will slide into a pin slot and will turn the center gear one increment at a time, and the direction can be reversed as well.
Thank you. This is Sort-Ware Solutions, and we look forward to showing you more progress in the future.